What's up, guys? Welcome back to the channel. Today on this video, as you can see, we'll be doing this previous question paper that you see here. This is a national certificate for mathematics and 4, and this paper was written on the 30th of July 2025, and it took about 3 hours to be written. So before we start though, I would like to inform you about the QR code that you see on the right. This is a QR code for our WhatsApp channel. You can join it by scanning the QR code, and also I'm going to leave the link of this WhatsApp channel on the description as well as in the comment, right? If you want to join this channel, click on that link. So before we continue though, this video is based on question 5 of this question paper that you see here. If you want to watch those videos, I'll leave a link that contains the playlist of those videos on the description, and also the very same link with the playlist. It will pop up on the top right of this video. Click on that icon and then you're able to watch those questions. All right, so before we start, let me just inform you that I'm gonna create the timestamps for each and every question, just in case you don't want to watch the videos in a sequence order. All right, so let's go and check question 5 and then let's solve it. All right, guys, here is our question 5. Now question 5 consists of 4 questions. So we're gonna start with 5.1, which has 2 questions underneath it. We have 5.1.1 and 5.1.2. So we're going to copy this question here, which is 5.1.1, and we solve it. Okay, we have copied the question. So let's read this question 5.1.1. Now the question goes like this: sketch the graph of y is equaling to e to the power of x, and y is equaling to e to the power of negative x, and x is equaling to 2, and also show the representative strip as well as the area to be calculated. So this question here, guys, they want us to draw these two graphs here, and also we are given a limit which is x is equaling to 2. So they want us to show a representative strip as well as the area that we're going to calculate. So let's start by drawing the first graph here. Let's call this one y is equaling to e to the power of x y1, right? So as you can see, x here is our exponent, so this becomes our exponential graph. So in order for you guys to draw the exponential graph, rather use the table, guys. So I'm gonna draw the table. All right, guys, so here is our table. So to insert the numbers here, guys, rather insert from negative to positive. So I will insert the smaller number, guys. Be careful when you insert the numbers here. Try not to insert bigger numbers because this is exponents, guys. So I'm gonna insert -1, -0.5, 0, 0.5, and 1. So all you have to do here is to substitute these x values them. Now we're gonna need our calculator to do that. So if you say e to the power of -1, this is gonna give us 0.4 approximately, right? If you say e to the power of -0.5, this is gonna give us 0.6 approximately. If you say e to the power of 0, this is gonna give us 1. And then if you say e to the power of 0.5, this is gonna give us 1.7. And the last one, when you say e to the power of 1, this is gonna give us 2.7. These are our answers, guys. So these are our coordinates, guys, when it comes to the points of this graph. So let's create the Cartesian plane and draw this graph. All right, guys, so here is our Cartesian plane. So we need to plot our graph based on our coordinates there. So I'm gonna use red for this one. I'm gonna highlight it with red. So this graph here, we're gonna use red color to draw it. Let's start with the first point. When x is -1, our y is 0.4. So -1, it's here. We're gonna draw a line that is going upwards, and our y is 0.4. It's gonna be somewhere there, guys. You guys see? There we go. When x is -0.5, our y is gonna be 0.6. So negative 0.5 is going to be somewhere there for x going upwards, and then our y is going to be positive 0.6. So it's somewhere right above 0.5 for y. So this is going to be our point. And then when our x is 0, our y is 1. So x is 0 on the y-axis, so our 1 is going to be there for y. So that is our point then. And then when x is 0.5, our y is going to be 1.7. So x is 0.5 on this side. Draw a line that is going vertical like that, guys. And our y is going to be 1.7. 1.7 it's in the middle of 1.5 and 2 of y. So this is the point then, right? Okay. And then the last point, when x is 1, our y is going to be 2.7. So you draw a line that is vertical. Don't forget, guys, you just draw a fainted line that is vertical going upwards. There we go. And then our y is 2.7. Again, 2.7, it's in the middle between 3 and 2.5. So let's draw a line there. Here we go. All right, guys, as you can see, I've created more space. So let's continue. Let's connect the dots. There we go. So here is our graph for this one here. Now let's draw another graph where y is equaling to e to the power of negative x. So we need to recreate again the table as well. So let's create the table. Alright guys, we have done with the table for this one. We're still gonna insert the very same x values for this graph. So we're gonna insert -1, negative 0.5, 0, 0.5, and 1. There we go. Then from there, we're just gonna substitute. So this time around, things are different. As you can see, we have negative there. So our values are not gonna be the same as the first one. So let's do it. When we have -1 as our x, when you substitute to our formula there, it's gonna give us positive 2.7. There we go. When you have x as negative half, this is gonna give us positive 1.7. There we go for y. When x is 0 or negative 0, our answer here is gonna be 1. And then when our x is positive 0.5, this is gonna give us 0.6. And when our x is 1, it's gonna give us 0.4. There we go, guys. So these are coordinates for this graph here. So we're gonna indicate this graph using the green color to show that it's a different graph. So let's plot the graph. So let's look at the coordinates here. The first coordinate, when x is -1, y is gonna be positive 2.7. So x is -1 here. You draw a line that goes up, 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 up. 2.7 is between 3 and 2.5 in the y-axis. So you also draw a line that is go to the left. Wherever these lines they meet, they create a point there. There we go. Then we go to the next point. When x is negative 0.5, your y is going to be positive 1.7. So we draw a line that is going vertically upwards, right? And then this point here, our y is going to be 1.7. So 1.7 is between 2 and 1.5 on the y-axis. So we draw a line again here. Where they meet, you draw a point. And then when x is 0, well, our y is going to be 1. So at this point, again, that's where our graph meet, right? And then we go to the point where x is 0.5, our y is going to be 0.6. So x is 0.5. Yeah, guys, draw a line that is going vertical. And y is 0.6, right above 0.5 there, guys. You draw a line that is horizontal heading to the right. So this is going to be our point. And then the last point, when x is 1, this is our 1, drawing a line that is going upwards like that. Our y is going to be 0.4. So it's under 0.5. Draw a line that is going on the right hand side. Then wherever they meet, this is going to be our point. Then you connect the dots. So let's connect the dots. There we go, guys. We managed to draw our graph, which is let's call it y is equaling to e to the power of negative x. So this is the second graph. Now, guys, we are given a limit, which is x is equaling to 2. So we need to draw a vertical line that is going upwards and then create the area that is caused by these two limits. So we have to draw a line. So I'm going to use black there to draw it. So from 2, you draw a straight line that is going upwards like that. This line here, that's where our limit is when you go to the right. Now, when you look at our left, the intercept, which is 0, 0 for x for both graph, it's where the other limit is. So from here, you highlight the enclosed area. So let's use a different color. Alright guys, we are done indicating the area. As you can see, I share it in blue there. Now it's time for us to show the representative strip. Guys, the representative strip, you can always put it anywhere as long it's within the shaded area. If it's within the shaded area, you can put it in the middle, at the beginning, or at the end of this graph of ours here. So here is our representative strip. Right, so do not forget to write change in x there. So basically this is how you do this question 5.1. It was a bit long and bit complicated, but really if you knew how to draw these two graphs, and also you understood that the limit that is given to us there, x is equaling to 2, was the upper limit. The lower limit is where the graph intercept there, where it's x is equaling to 0 for both these graphs. So make sure that you understood this. I hope you managed to understand, guys. If you have any question concerning how to draw this or how I solve this question, you can always leave a comment in the comment section asking a question. I'll try to answer you to my level best. But if this question helped you to understand, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. You can always rewatch at the point where you get lost as well, so that you don't ask a question only to find out you can understand if you watch for the second time or third time. So we are done with this question 5.1.1. Let's do 5.1.2. All right, we are done with 5.1.1. Let's look at 5.1.2. Now, 5.1.2, guys, here it is here. I'm going to copy it and paste it next to the graph because it's a continuation of 5.1.1. Okay, guys, here is our 5.1.2. Now, let's read the question and let's solve it. All right, guys, so the question goes like this. Calculate the area indicated between two functions by means of integration. So they want us to calculate the area that we indicated with the blue color there. We must use integration. So in order for us to calculate the area, guys, we need to use the definite integrals. So to use definite integrals, you need to find the upper limit and the lower limit. Remember from the question, guys, the upper limit was given to us here. We know that x is equaling to 2 from question 5.1.1. Now, the lower limit is not given to us, but we can find it from these two graphs. So the lower limit, guys, it's where this graph intercept. As you can see, these graphs here, they're intercepting at x when it's 0. So the upper limit, it was given to us in our question 5.1.1. So remember, you have to say sigma. So the upper limit here is going to be 2 because it's bigger than 0. And the lower limit here is going to be 0. So remember, we said y1 minus y2 dx. So if you still remember, y1, it was this one here. Let me just write one there. Y2, it was the green one there. I hope you can remember from question 5.1.1. All right, you might ask yourself now, why are we minusing y1 with y2? Now, let me show you something that you need to know, guys. As you can see, this area of ours, the graph that is on top there, we have two graphs that, guys, all right, I'm highlighting with yellow. The graph that is on top there, which is the red one, it's y1. So the graph that is on top of the area, just know that it is going to be positive. And then the graph that is beneath, as you can see, the green graph there, which is y2, is going to be negative. So whenever you calculate the area, consider which graph is on top of the area, which graph is beneath the area. The one on top is going to be positive and the one that is beneath is going to be negative. So let's substitute and solve. Right, so obviously we have sigma, upper limit is 2, lower limit is 0. Now we just substitute the y1, remember it's e to the power of x, minus y2, which is e to the power of negative x dx, right? So we integrate this. Obviously this is gonna be equaling to y, and then we integrate. Let's integrate e. What is the integral of e to the power of x? If you still remember, it doesn't change, guys. It's gonna be e to the power of x, and then minus. Now let's integrate the e to the power of negative x. So we're gonna multiply by the coefficient of x. In this case is negative 1 there, so it's gonna be negative, and then you multiply by the integral there. So the integral of e to the power of negative x is gonna be negative x, and then we close the bracket there, and then we don't forget to write our limit, upper limit and the lower limit. Now the next step, guys, here is to write our brackets for each limit. So let's start with the upper limit. So when you write the bracket for the upper limit, you're gonna have e to the power of x. Let's look at this. Minus multiplied by minus, this becomes positive, and then e to the power of negative x there. So this here is gonna be for the upper limit. The very same integral that we have for the upper limit is gonna be the integral for the lower limit. So it's going to be e to the power of x plus e to the power of negative x. But let's not forget lower limit. Guys, do not confuse the limits. I'm going to highlight them here with powers, right? These are just limits, guys. This is to indicate that our limit, we haven't yet substituted. All right, now, some of the things that you need to pay attention to, guys, is that the integral of the upper limit is always minus by the integral of the lower limit. So let's continue, my good people. So on the first bracket, we're gonna substitute x with 2 because 2 is our upper limit. So it's gonna be e to the power of 2 plus e to the power of negative 2. Remember, that one is negative x minus the second bracket. We're gonna write e to the power of 0 plus e to the power of negative 0, right? Then from here, guys, all you have to do is use your calculator. So let me create a little bit of space here, guys, to get the final answer. So if you put this on your calculator, 5,524 unit square. There we go, guys. So this is our final answer. I hope you managed to get this one, guys. This question, it looked a bit challenging, but really it was not. It was a matter of understanding how to calculate the area using the definite integral. So just in case you don't know how to do definite integrals, I'm gonna leave a video where I explain the definite integrals. So you can go to the description, click the link or the video of definite integrals, and also the very same video will pop up on the top right of the one that you're watching here. If that video doesn't help you, can always leave a comment on the comment section. I'll try to answer you to my level best. But if this part of the video help you to understand how to calculate the area, especially when you're given two graphs similar to this one, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. I hope you guys managed to understand this. So we are done with 5.1.2. Let's go and do the next question. All right, guys, let's look at the next question, which is 5.2. Now our 5.2, it's this one here. I'm gonna copy it, do it where there is space, and then we solve it. All right, guys, here is our 5.2. Now the question is simple and straightforward. They want us to just evaluate the following here. We have the sigma with the upper limit of 2 and the lower limit of 0. In the function here, we have 5 to the power of 2x dx. So they want us to evaluate this. So this is an exponential integral, guys. So in order for us to do this one, we need to integrate the function inside them. So let's integrate it. So when you integrate this one, guys, it's very, very simple. It's gonna be 5, right? 2x, then we divide by 2 ln then we have 5 as the base, and then we're still gonna have the upper limit and the lower limit. Guys, I've done videos on how to integrate the exponential, so you can go to the description. I'll leave a video where I explain how to differentiate the exponential, guys, right? And also the very same video will pop up on the top right of the video that you're watching at the current moment. Now, after doing this integration, remember these are definite integral, by the way. So after doing this integration, we have to subtract now. Now we have to subtract with the bracket of the upper limit with this bracket of the lower limit, right? So let's do this. All right, then we're gonna create another bracket of the lower limit with the same integral. So we have 5 to the power of 2x divided by 2 ln 5, and then here we're gonna write the lower limit. Remember guys, these are not powers, these are just limits. Let me highlight. The upper limit is 2, the lower limit is 0. The upper limit is 2, the lower limit is 0. And remember guys, that the upper limit bracket, it is minus by the bracket of the lower limit. Then from there, the next step here guys is to substitute our limit wherever there is x. On the first bracket, which is for the upper limit, wherever there is x, we're going to substitute by 2. So it's going to be the power of 2 divided by 2 ln 5. There we go. Minus. And then we go to the second bracket where we're going to substitute the lower limit. So it's going to be 5 to the power of 2 multiplied by 0 divided by 2 ln 5. There we go. And then you take this, put it in your calculator. Your final answer here is going to give us 193,856 unit square. There we go, guys. Remember, we use the definite integrals here on this one as well. As long as you see the limits, guys, it means that you must use definite integrals. So again, if you don't know how to do definite integrals, I already left the videos on definite integrals on the description. Go and watch those videos. Right, people, if this video helped you to understand how to solve such problems, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. You can always support our channel, guys, by hitting the super thanks button. But if you can do that, like and a comment will be highly appreciated. Okay, guys, so if you didn't understand, you can always go to the point where you didn't understand, rewatch at that point, and if that doesn't help, you can always leave a comment on the comment section. I'll try to answer you to my level best. We are done with 5.2, guys. Let's do 5.3. All right, guys, we are done with 5.2, and let's look at 5.3. So here's our 5.3 here, guys. So we're going to copy 5.3, and we're also going to paste it where there is space, and then we do it. All right, guys, here is our question 5.3. So this question is very simple, guys. They want us to simplify the following expression here, where we are given sigma 25 sec squared alpha minus 4 divided by 5 sec alpha minus 2 d alpha. So we are actually integrating with respect to alpha. Now we need to simplify this further before we actually integrate. Now if you can look at our numerator there, let me just highlight it very quickly. We have 25 sec squared alpha minus 4. So we can continue and simplify that numerator further because it's a difference of two squares. I hope you guys can see. We can write this as 5 sec alpha minus 2, right, multiplied by 5 sec alpha plus 2. There we go. And all this is divided by 5 sec alpha minus 2. In close bracket, let us not forget this is d alpha. So we remember we are integrating with respect to alpha. Now if you can look at the denominator, we have 5 sec alpha minus 2, and we also have on the numerator 5 sec alpha minus 2. So this 5 sec alpha minus 2 and that 5 sec alpha minus 2, they will divide each other. We'll be left with 5 sec alpha plus 2 d alpha. There we go. So from here we can start integrating. So let's integrate our expression there after simplifying. Now, if you can look at the first term there, 5 sec alpha, this is a integral of sec. So if you still remember, if you go to your formula sheet, guys, this one is going to give you 5. Then it's ln. What we have there is going to be sec alpha plus tan alpha. There we go. Plus, since we are having a constant here, remember when you are integrating the constant, guys, you just multiply that constant with the variable we're integrating with respect to. In this case, we are integrating with respect to alpha, so it's going to be 2 multiplied by alpha. So it's 2 multiplied by alpha. Since this is not definite integrals, these are indefinite integrals, our final answer we must write plus c. So this is actually how you integrate this question here. It looked difficult, but really it was not difficult, guys. So we are done with this question. I hope you managed to understand this question. Really, in order for you to solve this question, you first require to simplify the question and then you integrate. Then the integration of sec, guys, it's there on your formula sheet. So you all you have to do here, it was to substitute these values. All right. So if this video helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed to the channel. And if it so happened that you didn't understand, you can rewatch at the point where you got lost. If that doesn't help, you can always leave a comment. I'll try to help you to my level best. Guys, we are done with 5.3. Let's do the last question, which is 5.4. Now let's look at 5.4. So we're gonna copy the whole of 5.4 and then we're gonna paste it where there is space and then we solve it. Alright guys, here is our 5.4. Now 5.4, the question goes like this: integrate the following with respect to x. Now before we integrate this, guys, we need to notice or pay attention to each and every term, whether there is a term that needs to be simplified or not. So let's start with the first term. Now the first term, guys, we cannot integrate with cosec on the denominator or any other trigonometric ratio on the denominator. So we need to simplify this one. And then let's look at the second term. There's no simplification required. Third term, no simplification required. Fourth term, no simplification required. Fifth term, no simplification required. And then the last term, there's also no simplification required. It's only the first term that we need to simplify before we integrate. So let's simplify it, guys. So we have sigma there. Now when you simplify this one, guys, this is a inverse. Remember, we have 1 over cosec x. So 1 over cosec, guys, is the same as sine x. I hope you guys know this. These are inverses. So let me just erase this. So let's look at our coefficient there. We have 3 as our coefficient, and then we have 1 over cosec 3x. This we can change into sine 3x. There we go. Minus 7 multiplied by 2 to the power of 3x plus 2 pi multiplied by e to the power of 2x plus 10 to the power of negative 2x plus 3 pi divided by 6p minus cosec x multiplied by cot x, and then all this, it's dx there. Right, so I hope you guys can able to see what's happening there. The last term, guys, it might tempt you to simplify it, but the last term, guys, it is there on our formula sheet. When you go to the table of differentiation, you will see there is negative cosec multiplied by cot. Remember, differentiation is the opposite of integration, right? So but anyway, let's start here. Let's start with the first term. Rather equate this to y. Let's start. So we have the coefficient of 3 there, but the integral of sine here, guys, we know that is going to be negative cos 3x, and then we divide by 3. Now let's do the second term. We have minus 7 multiplied by 2 3x. Since x is our exponent, this is the exponential integral, which is 3, and then we say ln, and then our base here is 2. I hope you know how to do this one. And then the third term, we have 2 pi e to the power of 2x. Since x is our exponent, this become exponential. So we have 2 pi e to the power of 2x, but we have to divide by 2, the coefficient of x, and then multiply by ln e. There we go. Plus, and then the fourth term, also the fourth term, guys, it's a exponential because x is the exponent there. So we're gonna write 10 to the power of negative 2x, and then we divide by the coefficient of x there, which is negative 2 ln 10. There we go. Then we say plus the fifth term. So the fifth term, guys, as you can see, we do not have x, so it's a constant. Remember, when it's a constant, we multiply by the variable, which in this case the variable it's x. So we can just write 3 pi x divided by 6p. Right, now let's look at the last term, guys. Our last term, as you can see, we have minus cosec x multiplied by cot x. Guys, if you go to your formula sheet, again I repeat, on the derivative table, you will see that when you look at cosec, you will see that the derivative of cosec is negative cosec multiplied by cot. So we can reverse it and write plus cosec x plus c. That is your final answer, guys. So you can simplify it further, dividing this 3 and that 3, and you'll be left with negative cos 3x. And then the second term is fine, you're gonna leave it like that, 7 over 3 multiplied by 2 3x divided by ln 2. This is still fine. And then the third term, you have 2 and 2, they're gonna divide each other, you're gonna leave with 1, and we have ln e. Ln e is 1 on the denominator, so basically here on the third term we left with pi e to the power of 2x. And then the fourth term, we have 10 to the power of negative 2x divided by negative 2 ln 10. So this one, you're gonna make it to be negative because of that negative there, right? And then you're gonna write 10 to the power of negative 2x divided by 2 ln 10. Guys, this 2 and the 10, they don't divide because the 10 is the power of negative 2x. And then we go to the second last term, we have 3 divided by 6, that is going to give us half. So we can say we are left with pi x divided by 2p. There we go. Plus cosec x plus c. So this here, guys, is our final answer. I hope you managed to get this one. Just in case you didn't get it, I've made videos on how to integrate polynomials, so you can go to the link that I will leave on the description, click on that link, and also the very same link will pop up on the top right of this video. Go and watch those videos. It will help you to understand how to integrate all these terms that I just integrated here, right? If that doesn't help, you can always go to the point where you got lost, rewatch the video. And also, if that doesn't help as well, you can leave a comment in the comment section. Guys, we are done with this question paper. If this 5.4 help you to understand how to do polynomials, do not forget to like, share, comment, subscribe to the channel if you haven't subscribed to the channel. So we are finished with question 5.4, and we also finished with question 5 as a whole and the whole question paper, guys. I hope this video helped you to understand how to solve these problems. Guys, I really appreciate it when you watch these videos. Thank you very much, guys. Until next time, cheers.